You're using Pythag. What's the hypotenuse? 2. It's not you're solving for it. It's 2. One of the legs is 1, and you're solving for the other leg. So that's got to be on this side. 1 plus b squared equals 4. B squared equals 3. So b equals square root of 3 for BD. Okay, square root of 3. So let me just draw out before we get to the second one, and you tell me what the pattern is. I want to introduce you to our second special right triangle, which is called a 30, 60, 90. Let me put the values you just found for me. The hypotenuse was 2, this leg was 1, and the other leg was radical 3. Let's see one more, and then we'll test if there's a pattern or not. All right, so let's take a look at this 30, 60, 90. Find the lengths of the missing sides. So we're all good. Angle C is 60. That's how many degrees are left. So what would be BC? And then follow up, what would be AB? Don't write this in. Look, don't write this in, but imagine this is half an equilateral triangle. Because I got the 60 here. Remember, this was our diagram before. Pretend that's half of an equilateral triangle. Can you guys find BC for me now? You just did a full proof knowing these two are equal now. You just proved it by CP/CTC. So what about the length of BC now? BC, 3? This is your equilateral triangle, Eva, right?
Yeah.
One side's 4, meaning they're all 4. Right? And you just proved in the last proof, these two are equal.
Yeah.
So it's going to be
2.
2. BC is 2. And then how can I find AB? Little Pythagorean theorem. I got 2 squared plus b squared equals 4 squared. Go ahead. I'm not going to finish that for you. Simplest radical form for me. What'd you get? What did we get for that other side? Simplest radical form. 2? 2 radical 3. Yep, 2 radical 3. All right. Let's see if we can establish some rules like we did yesterday for the 45, 45, 90. If I am in a 30, 60, 90 triangle, we name it by its degrees, just like we did yesterday. This is why this is a little bit tougher than yesterday. The rules are a little more complicated than just multiply by radical 2. So in a 30, 60, 90 triangle, are the legs equal? Look at the two we just did. I rewrote them up here. Here are the 2 triangles we just did. Are the legs equal? No. No. So therefore, we're going to have to make sure we distinguish between the 2. I'm going to call the one across from 30 the smaller leg. Why am I going to call it the smaller leg? Anybody remember a couple units ago? Where's the smaller side located? Across from? Smaller angle. So I'm going to call the side across from 30 as the smaller leg. The side across from 60 is the longer leg. So can you guys help me find a rule that says the longer leg will be equal to what with the shorter leg? What do I do with the shorter leg to get to the longer leg? Look I had 1 as my shorter leg. I have radical 3 as my longer leg. 2 as my shorter leg. 2 radical 3 as my longer leg. Tavy, what do I do?
Multiply radical 3.
Times?
Times the smallest leg.
Shorter leg times radical 3. All right, the longer leg can be found by taking the shorter leg and multiplying it by radical 3. And then the second rule, how do you find the hypotenuse? Look at the hypotenuse, everyone, of both triangles we've just tested. What can I do to find that hypotenuse right pretty quickly? Look at the other sides and the hypotenuse. Joan, I got a suggestion?
The shorter leg times 2.
Yep, 2 times shorter leg. Good work. 2 times shorter leg. So everyone see the rules are, if we compare these to the 45-45, they're a little bit heavier here. It's not legs are equal and times radical 2. So again, the shorter leg is the one across from 30. Longer leg is the one across from 60. Anything you want to ask? I am going to go quicker now, but I need you to stop me if things are going too fast or you miss something. Because they're going to go pretty easy to pretty tough. All right, let's go then if you're fine. Okay, find the missing sides. We're all good that it's a 30, 60, 90. I don't have to put the 30 in there to establish that. All right, first question to somebody. What is the 12? Shorter, longer, hypotenuse. What's the 12? 18, what's the 12? Hypotenuse. So what I like to do is, I know the hypotenuse. Let me write out the hypotenuse rule. Hypotenuse equals 2 times shorter leg. And I'm just going to start just doing SL and LL for shorter and longer leg. 12 is the hypotenuse, so I plug it in for hypotenuse. Equals 2 times shorter leg. And some of you guys, look, are going to get to the point by the end of today, the end of tonight, where you don't need to do this. You know what it is in your head already. How do I get rid of the 2? How do I get rid of the 2? Sorry, I got to keep calling on numbers, I guess. 9, how do I get rid of the 2? Divide both sides by 2. So this tells me my shorter leg is 6. Shorter leg is 6. So you want to put a 6 there across from the 30, that's fine. All right, what about the longer leg now? Use your rule. Longer leg equals shorter leg times radical 3. Please, make sure you keep today and yesterday separate, because remember, yesterday we multiplied by radical 2. Yeah, now we're multiplying by radical 3 in a 30, 60, 90. Keep them separate. So my longer leg will be 6 times radical 3. All right. Questions? All right, next up, what's the 8? Shorter, longer hypotenuse. What's the 8? 1. What's the 8? Who's got 1? What's the 8? Shorter, longer, or hypotenuse? Shorter leg. It's across from the 30. Oh, great. When I know the shorter leg, I can start anywhere. Jonathan, what do you want? The longer leg or the hypotenuse? Your shot. Hypotenuse. Got it. Hypotenuse equals 2 times shorter leg. And again, you don't have to show me this. I know some of you can just double it by now in your head. 2 times 8, hypotenuse, 16. Done. Ready for the longer leg. Longer leg equals shorter leg times radical 3. Longer leg, 8 radical 3. Any issues? So let's face it, when you're given the shorter leg, think life is good. Life is good for now. What about 3? What did I start you out with on 3? Shorter, longer, or hypotenuse? 18, what do I start you out with? Shorter, yep. So what do you want to find? Hypotenuse or longer leg? Because we can find both. You got it, longer leg. Shorter leg times radical 3. 2 radical 3 times radical 3. All right? We did this yesterday. You can multiply those. 2 times radical times itself. Tammy?
Itself without the radical.
Number underneath. So 2 times 3. Longer leg is 6. Hypotenuse. 2 times shorter leg. 2 times 2 radical 3. What do you got for me there? 2 times 2 radical 3. Oh, 10.
4 radical 3.
4 radical 3. There you go. Any issues? All right, let's keep trucking then. Number 4, what did I give you? What's the 6 radical 2 referring to? Come on! 1, Meg. What's the 6 radical 2? Hypotenuse. So I'm like, oh, given the hypotenuse, I can write hypotenuse equals 2 times shorter leg. Uh-oh, we're in for it now. Ready? Hypotenuse, 6 radical 2 equals 2 times shorter leg. What do you want to do with the 2? I got to get the 2 out of there to solve for the shorter leg. 24, what can I do with the 2 to get it out of there? Yep, good. Divide both sides by 2. So my shorter leg, I can't cross off the 2's. One's underneath the radical, one isn't, but I could certainly do 6 over 2. So my shorter leg, 3 radical 2. And you're ready for the hypotenuse now. On the hypotenuse, we got, how about longer leg? Sorry. Longer leg, shorter leg times radical 3. 3 radical 2 times radical 3. We can't add them because what's underneath the numbers, underneath the radical is different, but we can multiply them. You can multiply anything you want, you just can't add anything you want. So this will be 3 radical 6. Whoo, boy. Heavy or what here? We all right? And I haven't done the toughest version, which is next. Here's the toughest spot you could be in. These two right here. When you're given the longer leg. That's the toughest spot you can be in with these triangles. All right, longer leg. So 6 radical 3, I already gave it away. I won't call anybody. That's the longer leg. So I'm thinking, all right, my rule is longer leg equals shorter leg times radical 3. Plug in 6 radical 3 for your longer leg. How do you figure out the shorter leg then? What do I do with the radical 3? 9, what am I doing with the radical 3? Yeah, just like you did the 2 earlier. Divide it out. And then look what happens on the left. What's going to happen? What's going to happen with those radical 3's? See ya. Gone. There's 6, your shorter leg. And then what would be the hypotenuse? I won't write it out, but what would be the hypotenuse then? I know the shorter leg is 6. What about the hypotenuse now? 15 when you're ready. What about the hypotenuse? Relax. Relax there, boss. 8.
12.
2 times 6, 12. Done. Questions from you guys? That wasn't too bad, right? The radical 3's canceled out. But what would happen if I divided by radical 3 and they don't cancel out? Here we go. The 12 across from the 60 makes it the longer leg. And I know that's shorter leg times radical 3. 12, longer leg, equals shorter leg times radical 3. I'm still going to ask, how do I get that shorter leg by itself? Oh, 9. How do I get the shorter leg by itself? Divide it, just like we've been doing all day. Ooh, nothing cancels out, though. That's not 4. Get out of here. Right? Nothing's going to cancel like it did in the last one. But we have a little bit of experience from yesterday that this is not an acceptable answer. Right? Can't have a radical in the decimator. Right, Paul? Darn right. Can't have a radical down there. How do we get rid of it yesterday? You guys that were here, how do I get rid of a radical in the denominator? Ones?
You multiply by radical 3.
That's karma right there, isn't it? That's karma. Yep. Radical 3 over radical 3. Oh boy, let's keep grinding. Shorter leg then is 12 radical 3 over 3. Right? Radical 3 times itself gives you the 3. 12 radical 3. Still not acceptable. Why not? What's your last step here? Still not acceptable. 2, 1, 21. Yep. So shorter leg is 4 radical 3. Making my hypotenuse. If the shorter leg is 4 radical 3, shorter leg, 4 radical 3, what would your hypotenuse be? 3, what do you think there, Eva? Redemption. 4 radical 3 times 2, 8 radical 3. Great job. Wow! Any head spinning? Are we good? Jonathan, how's your group over there? Great. Mahmood, how about that squad over there? Self-proclaimed best squad in the class, by the way. If anybody never heard that before. Good over there? Think you got this? All right. Ooh, can we do this now? Can we put 2 triangles in the same diagram that are special right triangles? Whoa. Whoa. What is he asking for here? I'm saying let's get nuts. That's what I'm saying. A through J, ridiculous, right? Ridiculous, Carlino, ridiculous. A through J. Guys, I'm not even going to look at it. I don't care what A through J says. Can you help me find every single angle in this diagram now? I'm going to call out an angle. You tell me what do you think it is. DCB. I guess I got to call in a number. That's right. You guys just don't respond. 14. We don't have a 14, do we? 18.
30 degrees.
30 degrees. Good. Angle ADC. Look at the one next to 60. ADC is 10?
120.
Buck 20. All right. Now from here, does everyone see I gave you AD and DC are congruent? You have an isosceles triangle there. Across from the congruent sides are congruent angles. Find angle A. Find angle A for me. That triangle is isosceles, meaning across from the congruent sides are congruent angles. Meaning angle A would be, when you're ready, 2?
30 degrees.
30? And that would mean angle ACD is also 30. Everyone's all right on finding those angles? All right, let's just fill in A through E right now because we've done it already. DCB was 30. CDA is 120. DCA 30. CAD 30. And then how about ACB? I just add up the 2 30s and I got 60. Okay. Do you see special right triangles in that diagram? I'm seeing some head shake. Yes. So name one special right triangle for me. Name one for me. 17. Where's there a special right triangle in this diagram? Name it by its letters. Come on. BCD. Correct. Triangle BCD is a 30, 60, 90. And look, I don't even care what this says I have to find. More than likely, I'm going to find everything. So ready, everyone, BCD, can you find the hypotenuse, the shorter leg, and the longer leg with me right now? I don't care what the problem says. You should have the ability to find all the 3 sides. Which one's given to us in that triangle? Which leg or hypotenuse is given to us? 7.
Shorter leg.
Shorter leg, 5. Use your rules now. Shorter leg's 5. What's the longer leg? 24, longer leg. I know the shorter leg. How do I get to the longer leg in a 30, 60, 90? 5 radical 3. And I need bonus here, Mahmood. Name that side. What side is considered the longer leg in BCD?
No, sorry.
CB. Everyone agrees? CB. 5 radical 3. How about the hypotenuse in that triangle? Name the hypotenuse. 1. How long is the hypotenuse? I know the shorter leg's 5. How long is the hypotenuse using my rules? 10. And I also, can you please name that side? That is 10. B, what is it? Sorry? DC is 10. Correct. All right. Questions there? Good job, everybody. I think there's another special right triangle in this diagram other than BCD. Name it. Where's the other special right triangle in this diagram? 10?
Triangle ACB.
The big dog. Triangle ACB is 30, 60, 90 as well. Hypotenuse, shorter leg, longer leg. Which one do we already know? Which one do we already know in that big triangle? The shorter, the longer, or the hypotenuse? 23 now. Which one do we know? The one across from 60?
The shorter.
Which is how long?
10.
Okay, here's the, you ready?
Oh, wait.
Remember, I'm glad you're doing this, Blake. ACB is the 30, 60, 90 triangle. I should only be given sides from ACB, nothing else. So here we go again. 5 radical 3 is the shorter leg. Does everyone see? Because it's across from the 30. I can only give you sides in that triangle, not any other triangle. All right, 5 radical 3 is the shorter leg. Longer leg, 5 radical 3 times radical 3. So the longer leg's going to end up being 15. And that is side AB. Now I get it. Some of you guys probably could have found that out differently, right? Because remember, we found 10 earlier and these are congruent. So 10 plus 5 would also give you 15. Finish it now. Hypotenuse. What is the hypotenuse length in triangle ACB? 19. What's your rule to find the hypotenuse first?
The shorter leg times 2.
What's our shorter leg? Don't move. Go ahead.
Radical 3.
Times 2.
And radical 3.
There you go. And that is side. Whoa, whoa, whoa. Caitlin's going to finish. She's a finisher. What side is that in the diagram, Caitlin?
AC.
Let's go. There you go. AC. 10 radical 3. Good job. Get the homework done tonight. It's important tonight. It's real important tonight. Not that it's not important every night, but tonight's got to get some practice in. Dig deep here. Let's go. You guys are going to be animals by the quiz on Friday.